Okay. Okay, so let's begin. Last year we learned two types of factorization. One is, as you said just now.
By taking out common factors.
Thank you. Taking out common factors. Okay. Oh yeah. Why you never tell me just now? Okay, it doesn't matter. You know what it is, okay? So the first one is by taking out common factors. Second one is factorization by, do you remember the second form?
Common factors. Grouping.
Correct, you are right. Okay, so you have to group it. Can you see the second version? Okay, for B. Can you see for B, right? 5x plus 5y plus x squared, xy plus x squared. First, you group the two of the front, the two terms. Then the second two terms. Okay, then you take out the common factor as well. So take out common factor after that. Okay, that's it. So this is about the first particular pattern. This is method 1 and this is referring to method 2. Okay? Different questions will require different answers, different methods. Okay? So this, someone say, right? Who was it who told me? What are A and X plus Y? No, just now somebody said it already. A and X plus Y are factors. Okay? Yes. Similarly, over here, the answer is exactly the same thing. These two, once you see that they are in brackets, they actually multiply each other, right? So they are also referring to factors. Okay? So this is on the first page, right? So if you're done, can you just digest the two examples there? Can I carry on? Okay, next one. Okay, page 2. Can you guys quickly try and do this on your own? It's not page 2. Slide 2, but the same page for you. Right, so I've done the first step already. So let's see, the first particular one, this is the final answer, cannot be further simplified. So remember, first you take out the coefficient, which is the common factor. Second, you take out the variables. Okay? Right, so for number 2, the first step is there. Next, what do you do?
Second one is Q.
Yeah, so okay, I can't change it for some reason. Okay, I'm going to do this. Okay, Q. Okay, so what am I essentially doing when I say I have to take this out? They are the same, so they are the same, and they are also, what allows me to take it out? They are both
Common factors.
common factors. That's the keyword, guys. Okay, it's common factors. So you got to take out the common factor. You are left with P minus Q. Okay, so this is your answer. Another thing for you to note, right, over here. Okay, is this sign changes. Can you see from minus becomes plus? Do you know why it changed? Correct, because of the minus outside the bracket in front there. Okay, so because of that, please don't forget, minus, when you have a minus outside the bracket, it becomes plus inside the bracket. Okay, then after that, take out your common factor and you should get your final answer. Okay, last one. Okay, last one, let's see. Okay, now, what do you notice about the common factor now? Is it really common? So how do I change it? Correct. You don't really times minus 1. What are you taking out? You're taking out the minus sign. Okay, if you remember this, A plus B is equals to A plus B, B plus A. Okay, no problem there. But when I do A minus B, can I do that? So what must I do? Okay? Remember this last year? Alright? Give you an example. 5 minus 3 is not equals to 3 minus 5. But this is 2 and this is minus 2. So what have I got to do to the second one? Insert a negative sign or take out a minus sign. Okay? See, depends on how you look at it. Right? So because of that, your answer here will become Q M minus N minus bracket M minus N. Thank you. And your answer therefore will become M minus N Q minus 1. Thank you. I'm glad a lot of you didn't forget the wonderful 1. Okay? Why? Because there is a silent 1 in front here. Okay, there is a silent 1 in front here. Let me lose the laser pointer. Then this one here. Okay, there's a silent 1. It must come out over here as well. Okay? Okay, let's just establish basically what is factorization? Factorization is the opposite of expansion. Okay, it's the reverse process of expansion. Okay, so basically factorization is going this way and expansion is going the other way. Okay, we will talk more about, okay, let me try. Okay, for example, okay, yeah, okay, so basically it is about the power. You know what's the power, right? The index, right? So when it comes to quadratic expression, you're referring to the highest power of the expression, and the highest power for quadratic is 2. Thank you. Highest power for quadratic is 2. Now highest power for linear factor is 1. Okay, see, this is a linear factor. This is a linear factor. The highest power is 1. Highest power 1. Okay, so highest power 2 is considered quadratic. And then for highest power 3, what do you think is the word for it? Thank you. Cubic. Okay, cubic equation. So you have linear, quadratic and cubic. Okay, so quadratic equations, I repeat, highest power 2. Whenever you see this kind of question, you know you're supposed to factorize it using the method I'm going to teach you after this. Okay, now, so A, is it a quadratic expression? Yes, obviously yes. Okay, because this is the highest power. So yes. How about the second one? This is the highest power. Is it a quadratic expression? No, this is called a cubic. Okay, then after cubic, right, we have a lot more. So we call them polynomials. Alright? Polynomials. Don't need to learn that. Okay, not yet. Okay, now I told you before already, this way, where you are getting rid of the brackets, what is it called? What's the process called? Thank you, expansion. So now we are concerned with going this way. It's called factorization. Okay. Okay, now I know some of you learn another method in tuition if you go for tuition. But today I'm going to use the most basic method, which is multiplication frame. Why? Because you are clear on how it's done. Okay. So this is called a multiplication frame. Okay. And this is multiply. If you remember, this part and this part is referring to the referring to what? The number that are what? The start with F. Thank you very much. This is the factors and factors, and this is the product, the final product. Okay? So, normally, what we do is we will actually write A plus 2, A plus 3. Am I right? Then you fill up the products. Do you remember this? Do you remember this, Tuji? Yes. So now I'm going to go backwards. I'm going to go backwards by doing factorization. Now, when I do factorization, right? Okay, get this y squared I put here, 3 I put here. Do you know why I put y squared and 3 there? I saw Hang Sam nodding. Why? Why? Why do I put y squared there? So that I can factorize it into 2, right? Into 2. What do you think will be in these 2 boxes? Y. Good. Okay? That's the first reason. I settle the term with the square first. Okay? Settle the term with the square. The first one will be y, second one will be y. Second, how do I know what goes here and here? By the 3. Correct. Okay? So 3 and 1. So the first important point when doing factorization, you have to determine the components of the factors by looking at the coefficient with the squared and the constant 3. That gives you the factors. Once you fill this up, double check. 3 times y is positive 3y. Y times 1? Positive y. All together how much? 4y. Does it tally? Yes. Therefore, is this your answer? Yes. And this is how you get back your answer on the left side, which is y plus 3, y plus 1. Can you see that? Do you understand how it's used now? Yes? For those who don't, put out your hand later, then I'll go around. Now, can you try the next question? Okay. This particular question, last one, right? Okay, the question is given is x squared plus 7x plus 10. Okay, now I'm going to give you a non-example first before I give you the correct version. Now, this is the non-example. First thing first, what do you fill up the box with? X squared. Thank you. Some of you really get it. Very good. X times x. Good. Then I know this is supposed to be 10. Okay, a lot of students who did it wrongly the first time is because they put it as 1 and 10. Technically, are you wrong in terms of determining the factors? No. However, you need to do your check. Correct. This is how you do your check. Positive 1 times x is x. X times 10 is 10x. Plus. You get 11x. Does it tally? No. That's why the answer is not correct. Okay? So, this box, right? Okay? I need you to understand. This box and this box serves as a check. Whereas, this box and this box serve as clues to your factor. Okay? Clues to your factor. Understand? Okay? Can. So, I carry on to the correct. I want x squared plus 7x plus 10. So again, x squared, x. X squared, again, is x times x. 10 must be, if not, what 1 times 10 is 2 times? Thank you. So those of you who got the right answer, straight away went with 2 times 5. So you get 2x here and 5x here. Plus. Is it 7x? Correct. Therefore, the answer is correct and you are supposed to write it as this factor times this factor, which is x plus 2, x plus 5. This will give me the factorized version of this equation. Can you see how we got backwards? Okay, can. Wait, Okay, Nigel asked, is it okay for you to write as this? Yes, that means to say it doesn't matter the factors, the order. 2 times 5 is 5 times 2. Same thing. Okay, 10 times 7 is 7 times 10. It's commutative. Doesn't matter the order. Okay, so today this is what you learn. Tomorrow we'll go on to the other method. Okay, so I hope you understand what's going on today.